Okay, good morning. My name is Anurag Kumar and from Mechanical Engineering Department in Rama University. And today I am teaching fluid mechanics topic. One is a very important topic, that is Euler equation of motion. So Euler equation of motion is a very important because when the flow generally occurs, there is a lot of forces acting on the fluid elements, and that forces is very important to analyze in real world. But Euler equation of motion is generally consist of only two forces, but we study first the lot of forces first, that is how many forces acting on the element. Suppose this is a element, fluid element, and there are a lot of forces F1, F2, F3, F4 acting on the body fluid element when the fluid is flow. So generally we have to consider the lot of forces and their study to how to make the Euler equation from these type of forces. So Euler equation motion generally taking the assumptions. First one is the flow is ideal. Flow is ideal. Another is flow is incompressible. Incompressible flow. And third one is incompressible inviscid. Okay, inviscid. And fourth one is uniform. Okay, then unsteady, steady. So these are the main assumption for the Euler equation as well as Bernoulli equation. So when the fluid is ideal, that means the flow is generally taking all the laws in ideal basis. Incompressible means the flow cannot be compressed at any situation like the water and oil. Inviscid, that means the viscous flow is not considered, that is viscous force is not considered. Uniform, that means the velocity is uniform. Steady means that the flow properties will not change according to the time. Okay, so these are the some assumptions made. Derivation of Euler as well as Bernoulli equation. Okay, so it is very important we decide how many forces acting on the fluid element. So number one force is, if we write the equation of the fluid, number of forces acting, so first one is gravity force. Gravity force, or somewhere is called body force. Another is pressure force. Third one is viscous force. And fourth one is turbulence force. And fifth one, very important, compressible force. Force. So when we write the equation for if the fluid is element, then it is always moving, or sometime it is rest on the pot. Then there are a lot of forces, that is the 5 forces acting, and there is another law. These forces will tend to move this fluid element in that direction of the resultant direction, and the resultant direction can be taken as the fluid motion, like Newton's second law. And Newton's second law, what it say? F equals to mass into acceleration. The force equals to mass into acceleration, and these forces will taken as a summation of all forces, in any arbitrary direction, that is a s direction. So this equation we have to analyze in case of acting gravity force, pressure force, viscous force, turbulence force, and compressible force. Okay, so we further going. So we have to write initial equation for the fluid motion equation, that is summation of F in the s direction, mass into acceleration in the s direction, as is the arbitrary direction. Okay, so what are the forces? Let first one is pressure force in the s direction plus F, the pressure forces after gravity force in that direction, plus then viscous Fv into S direction, plus F turbulence force in the S direction, then Fc is a compressible force in the S direction. These are the sum of the forces other than the mass into acceleration in the S direction. Okay, so these are the different types of forces. How it is represent? It is represent like this. This is one is acceleration. This one is compressible force. Compressible force. Then is turbulent force. Then it is viscous force. Then Fg is the gravity force. Okay, now last one is pressure force. Pressure force. Okay, so there are 5 forces acting on the fluid element, and the mass of the fluid element, acceleration of the mass fluid element in the direction of the S, that is the RB direction. So this is the fluid motion equation generally, and when we remove one by one different forces or neglect different forces, the equations will become their own names. They have different names. So first we consider eliminate the compressible force. If the fluid element neglect this component, compressible force, then the equation will become a Reynolds equation. So write the Reynolds equation. First one is, if we neglect the compressible force, that is FCS, then equation will become FPS plus FGS plus FVS plus FTS equals to mass into acceleration. So this equation is generally known as Reynolds equation. Reynolds equation. This is number equation 1, this is equation number 2. Okay, so this equation is where the compressibility is negligible, so this is known as Reynolds equation. So what next? We have to neglect the turbulent force whenever, because sometimes the flow is a laminar, is a uniform, and there is a no turbulence occurs. So this is we can neglect the turbulent flows. Many flow there have different types of flow. That is, sometimes it has no turbulence, only no turbulence, that means no disturbance of the flow, so that it is known as it is generally neglect the turbulent force. So further we have to another thing, if we neglect the FTS, then the equation will become, what will equation? FPS plus FGS plus FVS equals to m into acceleration is direction. Okay, so this equation is a very important equation because it considers all 3 major forces: viscous forces, gravity forces, and pressure forces. And this equation is number 3, known as Navier-Stokes equation. Navier-Stokes equation. All we said that is NS equations. It is a very important equation because when the viscosity is come into play in the fluid motion, then the Navier-Stokes equation is a very important thing. Okay, so viscosity is considering in NS equation, for gravity force is considering, and pressure force is considering. And then next equations come when the viscosity is neglect. That means water has the ideal. Generally, it is a no flow, no fluid is considering the ideal, but sometimes viscosity is very less, so that we can consider it no viscosity. So if FVS is neglecting or negligible. So Fp s plus Fg s equals to m into acceleration. Okay, so this equation number 4, and this is our equation that is known as Euler's equation, and we have to only considering this equation to derive the further. Okay, so Euler equations I have told earlier, that is the gravity force and pressure force is acting on the element. Only two component of the forces is acting, that is the pressure force or gravity force, or we can say gravity force as a body forces. So this is the equation for Euler equation. Now further we have to derive in the different manner what are the pressure, what are the velocity, what are the other components, we'll considering this. Okay, so we further go beyond our this Fg plus Fv. Okay, Fp s plus Fg s equals to m into acceleration. So we have to find what is the pressure force, we have to find what is the gravity force. So to finding out, we have to draw one element like a streamlined body. A streamlined body, that means all the layers of the fluid lines will be similar, no further crossing the boundary. So there is another streamline which is passing through the center. Okay, and this is a direction that is known as S, and the element having the length, considering small element, so that we considering only ds. Ds is a very small element, generally we derivative part. Another thing, what will be the body force? Body forces or gravity forces always acting downward due to the gravity. Okay, if the density of the flow is rho, then multiplied by the g is the gravity constant, and then the ds. ds is the cross sectional area. What is the cross sectional area? Cross sectional area is perpendicular to the flow of motion, that is known as dA. It is a very small, so that we can take this dA. So ds is the length and dA is the cross sectional area, so both are multiplying and become a volume. Okay, volume multiplied by the density become mass, and g is the acceleration, gravitational acceleration. So now next, what will be the pressure force acting at the first inlet? This is known as inlet. So pressure force will be P. P is the pressure force, and if we multiplying the cross sectional area, it will become a force. Okay, because what is this pressure? Force equals to P into area. Okay, so now what will be the force acting on the other side? So that is P plus del P upon del S into ds multiplied by, this is the pressure which is changed. What amount changed? It is a very small amount has been changed. So multiplied by the area, it will become the pressure force. So there are three forces, PdA, P plus del P upon del S into ds into dA upon, and another thing, the gravity forces acting, and this line will be making an angle theta. So here we can make another diagram. ds, this is a z direction, we can say this is the z direction. So this is dz, this is theta, so cos theta will become dz upon ds. Okay, PdA, it is a pressure force in the inlet direction. P plus del P upon del S into ds into dA, that is the force in the outward direction. ds is a small element, and rho g ds into dA, this is the gravitational force. Now we have to put first all the forces. Number 1, PdA in inlet direction of S. Second one is P plus del P upon del S into ds into dA in outlet direction of S. That is outlet direction. What is the direction? Opposite direction. Opposite direction. Now third one is gravitational force rho g ds dA in Z downward Z direction. Downward Z direction. Okay, so the three forces will acting on this element. Now we have to use this. We have pressure force, we have gravity force. Now we have two mass and acceleration. We have to find also acceleration. So what will be the acceleration? Let me after some time I will find it what is the acceleration. So putting these forces in this equation. So putting all the forces in equation number 5th. Equation 5th. So what will be this? Pressure forces P dA, positive sign, minus because it is opposite, P completely taking a bracket, plus del P upon del S into ds into dA. Okay. Now this is a complete minus negative sign. Okay, then minus what is this? This is the force, this is the force, and this force we have to consider, but this force is in downward direction, but we have to find the forces in the S direction. So what will be the force in the S direction? So there are two components. One component is perpendicular to angle and perpendicular to this line, and other is force this one. So this force in the x direction, and this is s direction, opposite x direction, this is the perpendicular direction. So we have to consider only this force. Okay. So what will be this force? This force will become from this direction rho g ds dA into cos theta. Okay. Got it? So this force in this direction, because this is the angle making on this line, so that this force will be cos theta. Okay. So what will be the force putting here? Rho g ds dA into cos of theta equals to m into as. Clear? So we have putting all the questions forces in this equation. So now we have to put the mass and acceleration also. So we have to find the mass and acceleration. Okay. Now what will be the mass? Mass is equals to rho into volume. Volume, what is this? ds into dA. This is the mass. Now what will be the acceleration? Acceleration is very important. How to find the acceleration? Generally, when we have studied the kinematics of flow in the fluid mechanics, so kinematics of flow will say that the acceleration of any direction will be showing that if the velocity is v, then dv upon dt, because it is a time dependent, if the time dependent, plus v into, if the arbitrary value, if u into du upon dx, plus v du upon dy, plus w du upon dz. So this is the equation which is studied earlier in kinematics of flow. So this is known as convective acceleration. Okay, and this is known as local acceleration. Okay, so this is the arbitrary equation. This is the equation which is finding the acceleration in any direction. So here is what is our direction? Here the direction is s, and if we considering the velocity of flow is v, if we considering the velocity of v in the s direction, then this equation will be modified in the s direction only, because it's the three-dimensional flow. This equation is belongs to the three-dimensional flow. So here this component or this component can be negligible. Only these two components can be utilized. Okay, so these two components utilized in case of the s direction. So as will be, let the velocity is v, then our equation dv on dt plus v into dv upon dx ds. Okay, so this is our equation. Now dv upon dt can be taking as 0. Why 0? Because I always earlier we have said that this flow is generally a unsteady, steady, not unsteady. Okay, in case of steady, there is a no velocity or no parameter will change during the time, so that this component can be 0. So only what remains? V into dv upon ds. So our acceleration will become v dv upon ds. So because of the flow is steady, so this steady flow derivative will become 0, only this comes to play. Okay, so as will be this one and m is into this one. So we can put these two things in our equation. So our equation will become P dA minus bracket P plus del P upon del S into ds bracket dA minus rho g ds into dA into cos of theta equals to m की जगह हम क्या रख सकते हैं? Sorry, we are putting the m in place of rho into ds into dA and then multiplied by acceleration, that is v into dv upon ds. Okay, so our equation will become completely lengthy and also some complex equation. Okay, so we can normalize it, we can cancel out something, so we open this bracket. Okay, so we can erase our above thing, we can erase it. Now this will comes to this one. Okay, so we opening this equation, P dA minus P dA, this will become multiplied this one minus del P upon del S multiplied by ds and multiplied by dA. Another thing, minus rho g ds dA cos theta, we can put the cos theta value dz onto ds, dz upon ds equals to rho ds dA into v dv upon ds. Okay, so you can see there are a lot of components we can cut. First one is this one component can cut, and another thing we can divide rho g dA, rho ds ds. So in the equation now divide rho ds dA. Okay, when we dividing the ds dA on both side, okay, so what will become? So equation will become minus del P ds dA rho only will come once rho into d del S. Okay, rho will come to the denominator and ds dA will be cancelled out. Another thing, minus rho ds dA only remaining g dz upon ds. Okay, what will become? This one, this part will become rho ds dA only v dv upon ds. Okay, so there is a minus sign, we can take from LHS to RHS. So what will become? Total equation will become rho del P upon rho del S minus की जगह plus g dz upon ds in place, so will become v dv ds. Okay, equals to 0. So this equation will sort out. Now ds in the denominator, so we can just eliminate it. 1 upon ds we can take common and go in RHS. So del P upon rho plus this will take from there to here, so v dv. Okay, ds will remove, only g dz equals to 0. So this equation in coming to the picture, and this is Euler equation. Okay, this is your Euler equation. This is a world famous equation, that is the Euler equation, which is derived by the Euler's scientist Euler, very well known scientist Euler. So this is the equation of Euler. And now another thing, how can derive the Euler equation, Bernoulli equation with the help of Euler equation? This is a part of the Bernoulli, is very simple. So generally all the examination will ask derive the Bernoulli equations from the Euler equation. So what will become? So integrating these each and every part with the help of mathematics. So integrate above equation as del P upon rho integrated plus V dV integrated plus G dash Z integrated equals to 0 is taking as a constant. So if we integrate the 0, then this will become as a constant. Okay, so what will become this equation? So if 1 upon rho is a constant, integrate only dP under the sign, the partial differentiation will go on, plus V outside, and then V cannot be outside because V is the operator, so V is always inside. Okay, plus G is taken as constant and dz equals to C. Now integrated, what will become? P, only P. So it can be written as P upon rho plus V integrated, that what will become? V square upon 2. Okay, then plus what will become? G dz, that means Z equals to C. Now what here, G is here, so we can multiply it by the in denominator or divide the Z in both sides. So that will become P upon rho Z plus V square upon 2Z plus Z equals to C upon Z, always become another C. So we can take this as C. Okay, so this is well known Bernoulli equation. Now this is our end of part. What we have did today, we have find the total number of forces in the fluid element. Another thing, what we have to find the Euler equation number of forces, only 2 forces acting on the fluid element when the considering the Euler equation, because the other forces will not play in the role because of we have some assumptions ideal, incompressible, uniform and steady. Okay, and non-viscous flow, that is inviscid flow. So from the above pattern we have derived the Euler equation first considering this element, and del P upon rho V dV and plus G dz, and after that we have derived the Bernoulli equation from our Euler equation. So that's it for today. Okay, thank you so much.